All right, we're going to do a few examples, more than a few. So proving these trig identities. Examples. Prove that 1 minus cos theta times 1 plus cos theta equals sine squared theta. You most of the time start with the left-hand side and prove that it equals the right-hand side. So the way you set it out is as follows. You say LHS, left-hand side is that 1 minus cos theta times 1 plus cos theta. Okay. What do you recognize that as? A minus B, A plus B. Different. So that is of this format. A minus B, so this is what you're thinking. You recognize that as they're the same. One's a minus, one's a plus. A minus B times A plus B is, what's the rule? A squared minus B squared. It's called a difference of two squares. So how do you do this? Isn't it 1 squared minus cos theta squared or cos squared theta? Isn't that 1 minus cos squared theta? Right? Now, what you have to show that that equals sine squared theta. Now, what I'm going to write on the side is my identity. Which identity do you think I'll write? You're trying to show that that equals sine squared theta. What did we just learn? That sine squared theta plus cos squared theta is 1. Didn't we just learn that? And if I rearrange it, so what does sine squared theta equal? 1 minus cos squared theta. So on the side, I put this. Cos squared theta plus sine squared theta is 1. Yep, if I take the cos squared theta over, I can see that sine squared theta is 1 minus cos squared theta. So therefore, this equals sine squared theta, which equals the right-hand side. So what you do, you start with the left-hand side is this. You manipulate till it equals the right-hand side. Okay? And if you need to do any little bits of working on the side, you can. We start with the left-hand side. Sometimes we start with the right-hand side. I like to start with the side that's got more things on it. So we will start with the left again here. So my left-hand side is sine A times sec A. Now, oh girls, this one's pretty easy. All right. You can't change sine A. So the left-hand side is that, which is sine A times, what's sec? 1 on cos A. Now, isn't that just sine A divided by cos A? Because it's sine A is on the numerator, cos A is on the denominator. Because what's sine on cos? Tan, which equals tan A, which equals the right-hand side. There you go. Sorry, I sort of ran out of room. That's pretty easy. I don't think they're going to be this easy. So, left-hand side is that. Sec, the only thing you can do with sec is that it's 1 on cos. So that's sine on cos, which we know is tan from the identities that we just learnt, which equals the right-hand side. So once you get to the right-hand side, you need to say equals right-hand side. So start with my left-hand side is 1 over sine squared theta plus 1 on cos squared theta. All right, you're adding two fractions. When you add two fractions, what needs to be the same? The denominator. So let's go common denominator. So look what we've got. We've got two separate fractions and we're ending up with one result, not two separate fractions. So I have to have, you've got to look at where you're going. The only thing you can do with two fractions without the same denominator is to make a common denominator. So how are you going to do that? Don't you multiply this fraction by? So cos squared over cos squared, and this one will be multiplied by sine squared on sine squared. Are you okay with doing the quick method for common denominator? That times that, that times that, that times that. So when you multiply, what do you get? Cos squared theta. This fraction gets multiplied by sine squared theta. And what's my new denominator? What's it going to be? Sine squared theta times cos squared theta. These two end up getting multiplied. You okay or not with that, girls? That times that, that times that, that times that. All right. Do you recognize anything? These are sine squareds, by the way, cos squared. Girls, so I've gone common denominator. What's cos squared theta plus sine squared theta? So I've got 1 over sine squared theta cos squared theta. You need to, yes, you need the reciprocal of each. But what that means, that's 1 over sine squared theta times 1 over cos squared theta. Do you agree that 1 over all of that is 1 over sine squared theta times 1 on cos squared theta? Why am I breaking them up? Because 1 on sine is which one? What's 1 on sine? Cosec. And what's 1 on cos? Sec. Which is that result there. And I can, which equals the right hand side. Okay? 90 minus phi over sine of 90 minus phi. We can do this 2 different ways. If you want, use the complementary ones, ratios. What's cos of 90 minus theta, for example? Isn't it sine? Sine of phi. So the cos of 90 minus phi is sine phi. And the sine, this is using complementary results, but I could have done it another way. And the sine of 90 minus phi is cos phi, cos phi, which is, I'm going to just go across, okay? Which sine on cos is tan. Now, my other way to do it was as follows. Or I could have gone like this. Cos of 90 minus phi over sine of 90 minus phi. Can anyone tell me the other way to do it? What's cos on sine? We know that sine on cos is tan. What's cos on sine? Cot of that. Because it's the cos of that angle over the sine of that angle, because they're both the same, you're doing cos on sine is cot. Now, what's the cot of 90 minus phi? What's its complementary? Tan of phi. So 2 different ways to do that question. Now, the only reason you can put straight away cot is because it's cos and sine of the same angle. Do you get it? Because we've just, remember, cot is cos on sine of the same angle. And they're the same angle. The other way is to use the complementary angles first and then use sine on cos. Sine of phi on cos of phi is tan of phi. You could have done it 3 or 4 different ways. So we start with sec squared x minus tan squared x. And you have to think, where have I seen sec squared? Where have I seen tan squared? I know, you know how we've got its? What's its? 1 plus tan squared x equals sec squared x. That would be nice. Why don't we change our sec squared x to 1 plus tan squared x? Does it sound good? So 1 plus tan squared x is that bit. So sec squared is 1 plus tan squared. We've made that substitution. And I've still got minus tan squared x. What does that equal? 1 plus tan squared x minus tan squared x is 1. Okay? Now, I could have done it another way. I could have substituted for tan squared x. So that's one way to do it. So that's simplified now. Sec squared x minus tan squared x equals 1. Or isn't tan squared x, if I use that, isn't it, no, be careful. What is it? Sec squared x minus 1. So I could have replaced the tan squared x. I want to do this one because this is a bit trickier, all right? And you may have to do this type of substitution somewhere. So this one, I would go with the first way, but you could have also done it this way, but this is a bit trickier. So sec squared x is okay, minus, now I have to replace the tan squared x. What do I need to put around the tan squared x? Like, it's minus all of this. I need to put brackets. Minus sec squared x minus 1. Do you know why I'm putting brackets? Because it's minus whatever tan squared x is, and tan squared x is sec squared x minus 1. So I've got to take that all away. When I open up my bracket, what do I get? Are you okay with this? sec squared x minus whatever tan squared x is, and it's that. So expand. Minus sec squared x minus -1 is plus 1 equals 1. The sec squareds cancel. Sec squared x minus sec squared x is 1. It's very much the same. Again, simplifying cot squared theta minus cosec squared theta. We know that 1 plus cot squared theta equals cosec squared theta. We know that. 1 plus little c equals big C. It's not the cos, and the c in this case isn't cos, because cos is already taken in cos squared plus sine squared theta is 1. So what are you going to replace? You're going to replace your cosec, or you're going to replace your cot. It's up to you. I don't mind. So we're going to replace cosec squared theta. So we've got cot squared theta minus cosec squared theta is more than one thing, so we have to use brackets because we're taking it all away. And then we expand the brackets. Now, please follow these steps. Don't say, yep, it's that. You're going to make a mistake. You may make one. Please put every line of working in. So it's take away 1, take away cot squared theta. What is the answer, girls? Cot squared theta minus cot squared theta is 0. They cancel. Answer is -1. Okay? Please show all working. And what I mean by all working is write this line out and then expand it. Write that line out too. And then we can see that cot squared theta minus cot squared theta cancel. We use the 1 plus because they had both the cot and the cosec. And there's a link between them. Sec squared, tan squared, there's a link between them. That's the good ratio to use. Here, if you go 1 plus cot, you're going to end up, see, we're trying to simplify it. We don't want to make two expressions. And if we go 1 plus cot squared, we've then got to do something with the cot, and then we've got to multiply the sine by each of those, and you're making it messier. So you've got two options for cosec. That rule, which is going to expand it and make it even bigger, or the other one is that cosec alpha is 1 on sine alpha, and that is the better one to use because you've got sine squared alpha times 1 on sine alpha squared, sine squared alpha, because there's, so if cosec alpha is 1 on sine alpha, then cosec squared alpha is that squared. It's 1 squared on sine squared alpha. So it's 1 on sine squared alpha. Now what's good about that? You get sine squared on sine squared, which is 1. Now that's much better than doing something else. Prove that sine y, cot y, sec y equals 1. So left-hand side is sine y times cot y times sec y. All right, sine can't change. What's cot?
1 over 10.
I don't know if I'd do 1 on tan. I'd do the other one because you want some cancelling. What's cot? Yeah, it's 1 on tan, but tan is sine on cos, so it's cos on sine. You know why we're doing that? Why do you think? Was that a good idea? What's already going to happen? Whereas the tan's not going to cancel with anything. So you've got two options for cot. 1 on tan. You'll only use that if there's another tan somewhere that it can cancel with. Or cos on sine. Remember, tan is sine on cos, so cot is sine on cos on sine. What's sec? What's sec? That's even better. What's so good about this? Cancel, 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 cancel. The sines cancel, the causes cancel. What are you left with? 1. Okay? Now, if you would have done 1 on tan, you're going to see that that leads you to a dead end. And you've got to cross it out and try the other thing for cot. Okay? Next one, cot over cosec. Simplify. Now, so we start with cot A over cosec A. Now, what I would do, I would write it side by side, cot A divided by cosec A. Why? Because they're both fraction results, and you don't want to do a fraction divided by another fraction. You'll end up with 4 lines. So whenever you're going to have a fraction divided by another fraction, you should write them side by side and change it to a division sign. Now, you can think what you want to use for cot. I probably wouldn't do 1 on tan because what is cosec? So I'd probably be doing not 1 on tan. I'd be doing, is it sine on cos? Yeah, I'd be doing cos on sine divided by, and the reason is I'm guided by cosec, which is 1 on sine. You know what to do now? Do the reciprocal. Cos A on sine A times sine A on 1. And what cancels? The sines, and you're just left with cos A on 1, which is cos A. Prove that sine A plus cos A all squared equals 1 plus 2 sine A cos A. Girls, that is A plus B squared is A squared plus 2AB plus B squared. So you have to expand it. That is of the form A plus B squared. So please do not just write that it's sine squared A plus cos squared A, because it's not. So if we use that, what do we get? Square the first one. Remember, and we use everything. Plus 2 times that plus the last one squared. Then what should you group together? What's sine squared plus cos squared? No. Yeah. So what I'm doing, sine squared A plus cos squared A, I'm just rearranging them. So sine squared plus cos squared is 1, and then we've just got the rest, which equals my right-hand side. That cos to the power of 4x plus cos squared x sine squared x equals cos squared x. Start with the left-hand side. You've got 2 terms. Anything you can do? Anything in common? Starting with x. Can you pull out a common factor? Cos, how many of the coses are common? Good. So cos squared x is your common factor. What's left to get that? How are you going to... See, cos to the power of 4x is cos x times cos x times cos x times cos x. So that's another cos squared x here. Are we okay? So there is definitely a cos squared x in common. So I pull it out. I still need another 2 cos x's. So like cos plus, I've got that already, plus. So this is pulled out. First term's done. What am I missing? Cos squared times sine squared. Got it? Cos squared x is in common. Pull it out. Cos squared times cos squared is cos to the power of 4. And cos squared times sine squared is cos squared sine squared. I'm pulling out a common factor. What does... That's right. So what does cos squared plus sine squared equal? (12c), which we just did on the board. Okay, you've got 2 options. So girls, I'd be looking where I'm heading, and you're heading for just one term. So I wouldn't be doing that this is 1 plus cot and this is 1 plus tan. You end up with too many separate things. There's no way you're going to end up with one term. So I'd be doing the reciprocal ratios, 1 over sine squared y plus 1 over cos squared y, because when you've got 2 fractions, you can make a common denominator, which gives you one term again. So cos squared y plus sine squared y over sine squared y plus cos squared y. Now, cos squared plus sine squared is 1. Sorry, that's times. So each of those is a reciprocal ratio, which is cosec squared y times sec squared y equals right-hand side. Okay? Now, the next one are not squareds, so you wouldn't be using squared things. You can only use what? The reciprocal ratios. All right, you know what cosec is? Yep. That's the only thing you can do. So that's 1 on sine minus sine. Well, you've got a fraction minus something else. What could you do? I'm thinking the only thing is common denominator. All right, so this is over 1 at the moment. Fraction minus something. Just write this as a fraction and go common denominator. You know why you want to go common denominator? You've only got one term at the end. And when you go common denominator, you're just ending up with one fraction, which hopefully will simplify to that. Okay, there's nothing else you can do. So I'll keep this denominator the same, but how do I make this denominator sine phi? I multiply by sine on sine. So I get sine squared. Now, I've got the same denominator, haven't I? Yep. Yeah, so I've got 1 minus sine squared over sine squared. No, over sine, sorry. You okay with that? The denominator is the same. So what I did here was go times sine phi over sine phi. Denominator is the same. Tell me what 1 minus sine squared is. Cos squared. So sine squared plus cos squared is 1. We know that. So cos squared is 1 minus sine squared. Please remember the relationship between sine squared, cos squared, and 1. So you don't always have to see sine squared plus cos squared. You can see 1 minus one of the other ones. Okay, cos sine squared plus cos squared is 1. 1 minus sine squared is cos squared. And 1 minus cos squared is sine squared. So what am I going to replace the numerator here with? So I've got cos squared theta over sine theta. All right, I'll need to turn over the page. Oops. Cos squared psi over sine psi. Now, I know that cos over sine is cot. So I write it as cos over sine, but times what? There's one of the causes times another cos. So I'm breaking it up. I want a cos on sine because I know that's a cot. And I'll keep this cos here. You okay with that? I've just broken up the cos squared phi into cos times cos. Cos on sine is cot. Is that our right-hand side? Is that it? Yeah. Equals right-hand side. Cot times cos phi. B. You can either expand first or change your sec and your cot. We'll change our second cot. So cos phi plus cos phi on sine phi times sec is 1 on cos phi. Now, most of the time you like to see that written at the front, but it's still that on the outside times each of these two things. You okay? So you'll be doing cos times that and that times that. And you want to show it. Probably would have been better to expand first. All right? So we've got cos times this one. And maybe put them in brackets. So really, pretend this is at the front. So it's that times that, and it's going to be that times that. Plus this times that. Are you okay with that? So I did this on the outside times each of those. And now you can go and cancel and do whatever you want. Cos and cos and cos and cos. So what's the first one? 1 plus, what's 1 on sine? What's 1 on sine?
Oh, it's sorry,
Which is right-hand side. F, prove that 1 plus cot x on 1 plus tan x is cot x. Now, you know, if I had a cos or a sine in there, I would have changed my cot to cos on sine, or I would have changed my sine, my tan to sine on cos. But it's just cots and tans. So I think you can just change your cot to 1 on tan. So I've got left-hand side, 1 plus cot x is 1 plus 1 on tan x over 1 plus tan x. Girls, you need to do something. You can't have 1 plus a fraction divided by this. What do you think you need to do with the numerator? There's a couple of things you can do here. Multiplying through by tan x. What we're really doing is multiplying the numerator and the denominator by tan, because we look at the denominator and that's what we want to get rid of. So the lowest common denominator of all this is the tan x. So I multiply the first thing by tan x, and then this gets multiplied by tan x, which gives me 1, and then this gets multiplied by tan x, and this gets multiplied by tan x. Now, we're hoping for some cancelling, but we can factorise out a tan x in the denominator. So I've got tan x plus 1 over tan x bracket 1 plus tan x. Now, it's tan x times all of that. If I put this in brackets, tan x plus 1 is the same as 1 plus tan x, they cancel. And I've got 1 over tan x, which is cot, equals right-hand side. Girls, I'm subtracting two fractions and the denominators are different, and I'm ending up with one thing. So you have to go common denominator. Whenever you've got two fractions, denominators are different, always a common denominator. So it's not too bad. That times that, that times that, that times that. That's just a difference of two squares. So we've got left-hand side is this. Sorry, everything's moving. So that times that. So 1 times that is just sec psi plus tan psi. Be careful. Minus 1 times that. I'm using brackets. You okay with that? That times that, that times that, and that times that, put it in brackets. That times that. Okay, that times that, that times that, that times that. Open up the bracket in the numerator. And you've got a minus b, a plus b in the denominator. So what have we got? Let's open up the numerator. Sec phi plus tan phi. What do I write now? Come on. Plus or minus? Minus sec phi plus or minus tan? Plus over. Now this is a minus b. A plus b is a squared minus b squared. All right, any cancelling in the numerator? No, 6. So how many tan thetas have I got? 2 tan theta. Now, over. Think of your squared ones. What are they? Cos squared plus sine squared is 1. What's the second one? Its. What's its? What is its? 1 plus tan squared equals sec squared. Do you want to use that one? Not a bad idea. 1 plus tan squared equals sec squared. So replace your sec squared with 1 plus tan squared. That's that done. Now what else do I write? I've done that. What else do I write? I've just expanded 1 sec squared. Yep, minus tan squared. What's so good about that? Yep, tan squared minus tan squared, they go. So you're left with 2 tan phi over 1, which is just 2 tan phi, which is the right-hand side.